Hi everybody. So in this video, I'm going to introduce you to the geometric distribution. We'll work through example 1 as an introduction, and then in example 2, we'll try an exam style question. And if you want to work along with me, you can download a copy of a PDF from my website. I'll leave a link below. So in example 1, we're told that Elizabeth is spinning the fair pentagonal spinner. We've been asked to find the probability of Elizabeth spinning a blue for the first time on her fourth attempt. So if we begin by drawing a probability tree, we start here. We can either get a blue, which has a probability of 2/5, or a white, which I'll call not blue. And this has a probability of 3/5. And we're told that she spins the blue for the first time on the fourth attempt. And this must be a not blue on that first attempt. Then we can move on to our second attempt. And again, the probabilities remain constant. So the blue would be 2/5, and the not blue would again be 3/5. And we know yet again she does not get a blue. So then we'll move on to the third attempt, where again probabilities are constant. So blue is 2/5, not blue 3/5. And we know again she does not get a blue. But then on the fourth attempt, we're told that she does get a blue. So that'll be this branch. Now we can use our tree diagram to find this probability. If getting a blue is a success, then we want 3 failures followed by 1 success. So the probability of 3 failures will be the 1/5, and so multiply by another 3/5 multiplied by another one. So 3/5 multiplied by itself 3 times, we can write as 3/5 cubed, followed by 1 success. So this one and 2/5. So multiplied by the success of 2/5. Then we can work this out on a calculator. 3/5 cubed times 2/5, and this will give us 24 over 625. So this is the probability of getting the first blue on the fourth attempt. And then for part B, find the probability of Elizabeth spinning a blue for the first time on the 10th attempt. Well, drawing a tree diagram now would be quite difficult, but this is where we can use the geometric distribution. What we can say is that x is distributed geometrically if the probability remains constant, which it does throughout the number of trials, and the outcome of a following event is independent on the outcome of a previous event, which it is because we're told it's a fair pentagonal spinner. So x is distributed geometrically with a probability of success, and we know this is 2/5 for landing on a blue. And this is our geometric distribution, and we have to define this x. This is our random variable. So we say x is equal to the random variable, the number of rolls needed for a blue. And then because we want the probability of getting a blue on the 10th attempt, we're saying that the probability of our random variable x being 10 is equal to, well, to get it on the 10th attempt, we must have had 9 fails. And if 2/5 is the probability of success, and you can either succeed or fail, then the probability of a fail will be 1 minus 2/5. And this must have happened the previous 9 times. And then on the 10th time you succeed, you do get that blue. So we've got 1 minus 2/5, which is 3/5, multiplied by itself 9 times, multiplied by 2/5, the success. We can work this out, and we get approximately 0.0187 to 4 dp. And we can use a formula to generalize this. If x is distributed geometrically, then the probability of our random variable being any observed value will be one success followed by previous fails. And if the success happens on the X attempt, then the previous fails must be X minus 1. And this is the formula to work out a probability for a geometric distribution. Let's try and use this formula in example 2. So now we're told that Jamie is playing a board game with a fair 6-sided dice, and to start his turn he must roll a 6. We're given that each roll is independent, and we've been asked to find the probability that Jamie starts on his first roll, then he starts on his 5th roll, and then he takes no more than 4 attempts to start. So because it's independent, and we're assuming that the probability remains fixed, we can use a geometric distribution. We'll say X is distributed geometrically. The probability of success, well, if it's a fair 6-sided dice, and we want to roll a 6, the probability of success will be 1/6. And then we need to say where X is the random variable, the number of rolls needed to roll a 6. And then for part 1, the probability of X being equal to 1, so we get it on our first roll, when this will just be 1/6. For part 2, the probability of X now being equal to 5, well, we can use our formula. We have X being equal to the observed value. The probability of X being equal to observed value will be one success multiplied by the number of preceding fails, which will be X minus 1. So this will be P, which is 1/6, multiplied by 1 minus 1/6, so 5/6. And then we must have had 4 fails. So we can work this out, and we get 0.0804 to 4 dp. And then for part 3, we want the probability of no more than 4 attempts. So this is where X is less than or equal to 4. It can be equal to 4, it just can't be more than 4. Well, there's a couple of ways of doing this. In the next video, I'm going to show you a different way. But in this video, we can look at getting it on the first attempt, or getting it on the second. You could get it on the third, or you could get it on the fourth. But you can't get it on any more than that. So for our first attempt, well, that'll just be 1/6. And then for X equals 2, you must have failed on the first attempt, but succeeded on the second. And then for X equals 3, you must have failed on the first 2, so that would be 5/6 squared, and then succeeded on the third. And then for X equals 4, failed on the first 3, so we'll cube that, and then multiply by 1/6, which is our pass. We can work out each of these. 1/6 plus 5/36, 25 over 216, and then we'll have 125 over 1296. We can add each of these together, and we get 305 over 1296, or at the decimal, approximately 0.2353 to 4 dp. Okay. For part B, state one assumption that we've used in our model. Well, we assumed that the probability of success remained constant. Okay, well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link below.